All right, guys, so welcome back again. So as I was saying about composite function, we are actually merging two functions to give you a new function, right? So we may start off with the two functions, one that we have, which is f of x, now, and one which is f of g. Sorry, not f, we have f of x and we have g of x. So the f of x function would be equal to 2x minus 1. And the g of x function is equal to 3x plus 2. All right, now what we really want to do is to merge into a single function. We may want to merge as f of x, that we can merge two functions, f of x of g, or we could merge g of f of x. All right, so in this case, we are merging g of f. So we are putting in the function f into the function g. And in order to do that, what we do, we take the function f, which is what we have here, 2x minus 1. And we are going to put that function wherever the x is in the function of g. We're going to replace it with 2x minus 1, but we're going to keep the 2x minus 1 in brackets. So once we have done that, then we would get this as we have here. So you would have g of f. We put the function of f in g where the x would be, and we keep the function in brackets. Is that clear? Is that clear to everybody? Guys?
Sir, can I go over it one more time, please?
All right. So we're going to do quite some practice with these, but I just want you to get an understanding. All right, so let me clear what I have here. So here we are given two functions. Now let me write it in a form that you are a little bit more comfortable with. So let's say we have f of x, and that is equal to 2x minus 1. Then now we have g of x. And g of x would be equal to 3x plus 2. And they say you have to find g of, so this is the composite function, g f of x. All right, what this really means, the function that is to the right, when you compose the two functions, whichever function is on the right side, you're putting in that function in the function of the left side. So in other words, you're putting in the function f into the function g, right? And that's the order in which we do it. So if you have the function in this order, you're putting in f into g. If you have the function f of g of x, then what we are doing here is now putting in the function g into the function f. All right, so this order is very important in determining which is going into which. So the one that is on the right side is going into the one that is on the left side. All right, is that clear so far? Now, if we are to find, question?
No, sir.
All right. All right, so I'm going to do both of these. So let us first look at g f of x. Now what this one is saying, we are going to put the entire function of f where x is in g. So what's the entire? So the right side would be 2x minus 1. So you can keep this in brackets. Now what you do, you take out the x and put the entire bracket of 2 minus 1 where the x is. So this would become, so when you merge this now, g f of x would now be equal to 3 . Remember now, we are replacing the x with the entire function of f. So we keep the entire function of x in brackets. So that would be 2x minus 1. We put that where the x would be in g. And then we add back the 2. And so this now would give you the composite function of g of f. Now you could further simplify this by removing the brackets. So you would say 3 times 2x will give you 6x. And then, sorry. So we would have 6x. And then 3 times negative 1 will give you a negative 3 plus 2. And now what you're going to do next is just simplify the negative 2, sorry, the positive 2 with the negative 3. So if you add positive 2 to negative 3, you will get negative 1. So this becomes 6x minus 1. So this is now the simplified version of g of f of x, all right? So therefore, g of f of x is equal to 6x minus 1. Is that clear? All right, so we're going to look at fg of x. Now, what are we going to do this time? Now, what I'm going to ask you to do is to try fg of x, and then I'll do it for you. All right, so let me give you a couple seconds to try that. All right, guys, you may raise your hand when you finish. All right, so my screen is finished. Anybody else tried it? Anybody else? All right, Ms. Dorothy. All right, so what did you get now for your answer for that one, Miss Green?
6x plus 3.
All right, so walk me through the process. So what are we going to do now?
So you're going to put 2. Then you put in bracket 3x plus 2, close bracket minus 1.
All right, hold on a second there, Miss. All right, so here we have f of x equal 2x minus 1. So what is it we're going to do now? Miss Green.
So you're going to write 2 open bracket 3x plus 2 close bracket minus 1.
All right, 2 open brackets 3x plus 2 close brackets, and then we have minus 1. And then we simplify that, removing the bracket, we get 6x plus 4 minus 1. And that will give you what? 6x
Plus 3.
plus 3. All right, good. All right, let me see the hands of those who got that. All right, very good. All right, so that's what composite function is about. Now it can become a little bit more complex depending on the kind of functions that you have. All right, so let me clear what we have here. Now, the definition, gf of x means to put the function f where x is in the function g. Now, in other words, we substitute the entire function f of x for x in g. Now, here we would have gf of x, put in the function 2x minus 1 in g. So we simplify that to 6x minus 1. Now, note that composite functions are seldom commutative. What that means, anybody knows? Anybody remember what the commutative law states? Anybody remember the commutative law? The order in which we add or multiply numbers don't affect the result. So with the commutative law, it means that if you're adding 2 numbers, so A plus B, and you switch the order, and then you put B plus A, then they would be equal, right? So the order wouldn't affect the result. Likewise for multiplication, A times B is the same as B times A. All right, so that's a commutative law. Now, why do we say that the commutative law are the composite functions are seldom commutative? What that means? Anybody? What is it saying? Seldom here means sometimes. They are rarely commutative. That means they can be commutative, but they are not always commutative. So what it really is saying is that if you have the composite of 2 functions, so if you have G composite F, it is not always or usual to be the same as F composite G, right? So they're not the same. If you say G f of x, it's not generally the same as f g of x. All right, and you would have seen it from the two examples that we worked first, because we get two different functions when we finish simplifying. So this is what that means. So in general, gf of x does not equal to fg of x. Now it can happen, but it is seldom. All right, so gf of x will give you 6x minus 1, but fg of x will give you 6x plus 3. And you see that the two composition give you two different results. Gf of x give you 6x minus 1, but fg of x give you 6x plus 3. So in that regard, we say that they are not commutative, because if we change the order, we don't get the same result. All right. All right, so here we have some other examples, and you're to find these. Now, I'm just going to give you a chance to try these on your own, and then I'll go through them with you if we have enough time to do so. Let me see what the time is like. All right, so I'm going to give you a little time to try the first, well, I must say, try all of them. See if you can do all of them. No. And let's see what happens in the time. So I'm going to give you these. All right, so I'm going to ask you to try all of these. So wherever the time runs out, then we'll stop there and we'll continue next class on them. All right, guys, so try this. All right, guys. Anybody getting anywhere with these questions? Anybody finish question A? Let us see who can produce an answer for question A. Who wants to walk me through question A? I'm waiting for someone to volunteer to work through question A for me. Guys, let me see the hands of those who are actually working on the questions, because everybody is silent, so I'm not sure. Are you doing the questions? Raise your hand. Okay. All right, so all right, you know what I'll do? Take a screenshot of the question and then finish them for homework. And then when next we meet on this topic, we will go through them together. And then now we will continue. All right, guys. So raise your hand when you're through taking a screenshot so that I can go ahead and stop. All right, Miss Cabrera. All right, Miss Green. Miss Dorothy. Anybody else need to take a screenshot? I'm going to
Chair took on.
huh?
Chair took on.
Okay. All right, guys. If you're through, I'm going to be stopping here, and then I'm going to stop sharing. All right, guys.